Today we will discuss the engineering of the airplane window. You're sitting at 35,000 feet. Outside that thin sheet of acrylic, the air is thin enough to kill you in seconds, and the temperature is colder than the surface of Mars. Between you and a catastrophic vacuum is a window, and right there at the bottom is a hole. Most people never notice it, but if you do, your first instinct is usually panic. Why is there a puncture in the only thing keeping the cabin pressurized? Did a seal fail? Is the plane structurally compromised? You look around, but the flight attendants are calm. The person next to you is sleeping. Yet that tiny opening is venting air right in front of your face. In the world of aerospace, a hole is usually a disaster. But this specific hole? It's the reason the window doesn't shatter. Today, we're deconstructing the invisible physics of flight to explain why the most dangerous-looking thing on your plane is actually the thing keeping you alive. To understand the hole, you have to understand the sandwich. Your window isn't one piece of glass. It's a 3-layer system. The inner pane is just a scratch cover to keep passengers from poking the important stuff. The outer and middle panes are the structural here. At cruising altitude, the cabin is pressurized to feel like 8,000 feet, while the outside air is incredibly thin. This creates a massive pressure differential. Without that tiny hole, the pressure would be trapped in the gap between the middle and outer panes, potentially stressing both until they fail. The hole bleeds the pressure so that only the outer pane takes the hit. But what if the outer pane fails? This is where the engineering gets genius. Because the bleed hole is so small, if the outer pane were to shatter, the middle pane becomes the primary barrier. It's a backup lung. The hole is small enough that the plane's pressurization system can easily outpump the air escaping through it, giving the pilots plenty of time to descend safely. And then there's the Antarctic problem. At high altitudes, moisture in the air gap would instantly turn into ice crystals, blocking your view of the Grand Canyon or the Atlantic. The hole allows for a tiny bit of airflow that acts as a natural defroster. We didn't always know this. Early aviation was a trial-by-error nightmare. We learned through mid-air failures that sharp corners and rigid structures don't survive the cycle of expansion and contraction. The bleed hole is a lesson written in the history of safety, a tiny intentional weakness that creates a much stronger hole. So the next time you're staring out at the clouds and you spot that tiny, suspicious-looking hole, don't worry, it's breathing. And as long as it's breathing, you can too. Thanks for watching. Subscribe for more informative videos.